Go ahead and read. We need to design square tied column. So, two information right now, square and the tied column, to support an axial dead load of 130 kb. So your dead load reaction equal 130 kb. And an axial life load reaction equal 180 kb. And the concrete strength F prime C for 1000, F yield grade 60, so F yield will be 60,000 PSI, and this one is PSI. Okay. So just a second, guys. I'm sorry, just a second. Sorry, guys, I'm back. So first step, what is the ultimate load on your column? P ultimate equal 1.2 dead load plus 1.6 life load equal 1.2 130 plus 1.6 180. So the axial load on this column will be 444 kb. We would like to design a tied column. So phi Pn equal 0.8 phi 0.85 F prime C area gross minus area steel plus F yield time area steel. Do you remember this equation? Just a hint. What is the design philosophy behind ultimate state? P ultimate smaller than or equal phi Pn. If you would like to design from scratch, I'm gonna assume P ultimate equal phi Pn. That means this side part will be 444 kb. But on the right side, we have two unknowns right now. Do you know what are the unknowns on the right side? F prime C is given. F yield is given. So what are the unknowns on the right side? Any answer? What are the unknowns on the right side? Phi equal 0.65. So what are the unknowns? We have two unknowns. Do you know them? Yeah. Area of concrete and area of steel. That makes sense. So how can I solve equation with two unknowns? Okay, guys. We can assume area steel equal 1% until 8% of area gross. Do you remember this limit? Do you remember this limit? You are a designer right now. You need to design. If you have more steel reinforcement, we will have less concrete. If you have less steel reinforcement, we will have more concrete. So we need to assume we need to assume which percentage. The question is, which one I'm gonna assume? 1%, 2%, 3%, 5%, 6, 7, 8. It's up to you. You are a designer, so take a decision. You have a range. Please select one from this range. I'm sorry, select a value from this range. So I'm gonna assume, and it's up to you in the exam, assume area steel equal 2% of area gross. That means area steel equal 0.02 area gross. That's right. That's right. So your equation, to make it clear here, 444 times 1000 to be inbound equal 0.8 times phi 0.65 times 0.85 F prime C. What is the value of F prime C? 4000 time area gross minus area steel. That's right. What is the value of area steel right now based on your assumption? Equal 0.02 area gross plus what? Fe 60,000 time area steel, which is 0.02 area gross. 60,000 time 0.02 area gross. I have question. How many unknowns do you have right now? How many unknowns? It's only one. Which one? Which one? Area gross. So, Oliver, what's the common column cross section? Okay. Just let me finish it and I will answer your question. Okay, I will do my calculation and be careful. Everything inside this big bracket is multiplied by this value. So be careful. 0.85 times 4000 times plus time 0.8 times 0.65 divide. So your area gross will be 188.4 inch square. This area gross will be converted to cross section, concrete cross section. So how can I convert this area gross to this cross section? Please read your problem carefully. We are looking for a square column. That means this side will equal to this one. So I'm going to take square root for this one. So it looks like 13.7 times 13.7. We would like to make your dimension integer numbers. So I'm going to assume it 14 inch times 14 inch. Oliver, the question said, what is the typical dimensions of the column? I don't know, but I have a recommendation here based on ACI saying the minimum column dimension is about 8 to 10 inch. The minimum dimension used in design 8 to 10 inch. If you use 8, that's fine. If you use 10, that's fine. Do you think 14 times 14 below or over the limit? We are good. We are good. So area steel will be 2% of the area gross. Do you remember? You assumed this. You assumed this in your design. So please complete your assumption. So 2% from what? This one or 14 times 14? It's not a big deal. If you use this one, that's okay. If you use this one, will be more okay. Okay, it's up to you. Because do you remember 13.7? I modified it to be 14, so I have a new area gross. Anyway, it's not a big deal for this one. 3.92 inch square. What is the next step, guys? We need to convert. Don't tell me, hey, we have area still equal 3.92. I cannot understand. I am a worker. I'm not engineer. I'm a worker. What is the meaning of this one? I cannot understand. You need to convert. You need to tell me how many and what is the size of the bar. So I need to answer these. Okay, what do you think? Let's assume number 5. 5 is good. Open your table. Number 5, the area is 0.31. So divide this area steel by 0.31. I need 12. Too much? Actually, for practice, we need this number to be even number. Do you know why? Okay, let's try to distribute 13. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. So this is 13. We don't have symmetric cross section. We are looking for symmetry of reinforcement distribution. So please, if your required number is odd number, please add one more to make it even. So 14, number 5, or change this size to get an even number. Okay, so I will add one here to be symmetric. So we have 14, number 5. This side is 18. Is it 18? No, it's 14 inch, and this one is 14 inch. This is the design. So final answer, I give you the dimension, I give you the number of bars, and I draw the cross section. So in any problem, I'm asking you to design a column and the column is not given, please, final conclusion of your calculations to draw the final shape of the column. Anybody has any question? You have any question? It's a piece of cake. Let me ask you a good question. Anybody can tell me what is the big issue? What is the big concern to design a column? This problem, what is the issue? What do you think? What is the big issue? What is the most difficult part in your design? Any answer? I would like to remind you for expression, these calculations are donkey work. If you give me, oh, okay, let me listen for you first. So anybody can tell me what is the big issue for any design? So if I have a building like this one, yeah, designing of column is a piece of cake. But what? Mm-mm. Mm-mm. No, 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 no. Oliver, can you explain your answer a little bit more, in more details? This example is very simple. You are looking to it as very simple. The example I solved right now is very simple and very straight, very easy to design and get the final shape of the column. Because what? Yeah, I know, Oliver, I know. But thank you. Yeah, Angel. Oliver, he is trying to explain what you said. If I know how much did load and how much life load on this column only. Guys, can you tell me what is the reaction on this column? How much did load and how much life load coming from this beam and this beam and this beam and this slab and this structure to this specific column? If you give me this reaction in a minute, I can give you the final design for this column. That's right? That's right? So the big issue, so I'm trying to return you back. The big issue is structure analysis. Give me reaction in a minute. I can give you the design. Give me a reaction. I can give you the design of any column, whatever the type. So the big issue is reactions. We need to make loading. This beam is supported by this column. This beam has uniform distributed load W ultimate. If you can figure out the reaction on this support, this reaction will be reaction on this column. That's right. So guys, these loading are very important. You need to understand this loading. Just a second. I'm sorry, guys. I'm sorry. Just a second.
You are now.
I'm sorry. Any question? Any question? I know it will be hard to figure out the reactions on any column because you have many beams and you have many slabs and you have many things in one structure. As I promised you, we will work on a project by the end of the semester. These reactions and these calculations will be done in a minute. Structure analysis for any floor plan, moment on slab, moment on beam, shear on beams, reaction on columns will be done in a moment. Don't worry. But you need to understand the concept, what's going on. Okay? Let's start the second type of column, which called spiral column. Guys, I told you spiral column means we have a column, whatever the shape, circular or rectangle or square, but it's most of the time it's circle. Anyway, it's not the shape is the issue, but the shape of the transverse reinforcement. It's one unit. Continuity of the stirrups in a shape called spiral reinforcement. And we have vertical reinforcement, which is called longitudinal reinforcement. We have two steps. If you would like to design spiral column, we have two steps. The first step, we need to design this spiral. This spiral reinforcement, we need to design it. What you mean to design it? I mean, I need to figure out what is the pitch and what is the diameter. Okay? What is the pitch and what is the diameter of this spiral? Anyway, we have two equations. The first one, rho S, which is percentage of spiral steel, equal 0.45 area gross divide area concrete. By the way, area C is the area inside this spiral. Area of concrete inside this spiral only. F prime C, F yield, so I can figure out the raw steel reinforcement. This rho also equal 4 area S DC minus DB divide S time DC square. We have some expressions here. DC is the diameter of the core inside this stirrup. This is DC. DB, diameter of the spiral. DB, only diameter of the bar. AS, cross-section area of the bar of the spiral. Guys, for any size, we have diameter. For example, for number 4, we have diameter and we have area. We have diameter, this is called DB. We have area, which called AS in our column. S, I didn't define it. S the pitch, the spacing between this one and this one. This is called S. Between this one and this one. Between this one and this one. Okay. So I can design. For this one, I will have a new two unknowns. What is the area S? What is the pitch between this part, this point, and this point? So you can assume what size of reinforcement you are using. So I can figure out the S spacing. This is the first part. Second part, design strengths of a spiral column equal 0.85 Phi, 0.85 F prime C area gross minus area steel plus F yield area steel. Wow. Anybody can watch? Can you watch this equation? What do you think? What do you think about this equation? It's identical. It's identical to the previous one for tight column, except this part, it's 0.85, not 0.8. And this phi equal 0.75 for a spiral column. It's not my it's not my number. They are provided by ACI. They are provided by ACI. Let's start for this one. First example, we need to design the strengths of the short spiral column shown. What is the design strength? Design strength for a spiral column phi Pn equal 0.85 phi 0.85 F prime C area gross minus area steel plus F yield time area steel. One by one. This is the equation. Because you are talking about a spiral column, I'm going to use this equation. What is the value of area gross? It's a circular column. Yes. The diameter of this column is 22 inch. Yes. So area gross will be pi divided 4 times 22 square. So pi divided 4 times 22 square will be 380.13 inches square. What is the value of area steel? How many bars do you have? 8. Number what? Number 8. Okay. Open your table. Number 8 bars with area 0.79. So your area steel will be 8, the total number. The area of 1 bar of number 8 is 0.7, how much? 79. So 8 times 0.79, your area steel will be 6.32 inches square. So right now I can substitute these values in this equation. Your design strength of the column will be 0.85, phi 0.75, guys, phi for a spiral column 0.75, don't forget it, time 0.85 F prime C 3,500, area gross 380.13 minus area steel 6.32 plus F yield 40,000 time area steel 6.32. Your final answer will be in pound. Your final answer will be in pound. How much? 870,114 pound. I'm gonna divide it by 1,000. It will be 870.1 kips. So this column with this dimension and this reinforcement can support a reaction until 870 kip. More than this force, collapse will happen to this column. It's easy. Just read your problem carefully to determine which equation I'm gonna use. Actually, both of them the same equation, but a little bit of different factors. So this is spiral column. So I'm gonna use this one, and the phi for a spiral column is 0.75. Any question? Looks good. Looks good. We need to design spiral column to support factored load. One of you will ask me, factored load. Factored, that means this value is multiplied by the factors, 1.2, 1.6, and these factors. But this value, is it dead load? Is it live load? I don't care. It's a factored load. So we have B ultimate equal 375 kip. Coming from structure analysis, this column in a building and the reaction coming to this column after you applied factors for dead load and the live load and all of this stuff, the final reaction will be 375. We need to design spiral circular column. I have to tell you this. We need to design a spiral circular column. F prime C 3000, F yield 50,000 psi. Okay, spiral column. Yeah, spiral column. Okay, so phi Pn equal point. I have to write the equation first. 0.85 phi 0.85 F prime C area gross minus area steel plus F yield area steel. Your design philosophy, we are looking to make B ultimate smaller than or equal the design capacity of the column. If you would like to design from scratch, I'm gonna assume P ultimate equal phi Pn. So this side will be 375 times 1000 to be inbound equal. Right side 0.85 phi for spiral 0.75. 0.85 value of F prime C is given 3000. Area gross, I'm looking. Area steel, I'm looking. F yield 50,000. Area steel, I'm looking for area steel. How many unknowns do you have in this equation? We have two, area gross and area steel. Okay. For spiral column also, we have a range, minimum percentage, 1% to 8%. So the ratio between area steel and the area gross, 1% to 8%, you have to select a value. So I'm gonna assume, and it's up to you. It's up to you. You are the designer. I'm gonna assume area steel equal 1%, 3%, 1.5%, 2.5%. It's up to you. You can assume what you want, but in this range. So what do you think? Okay, I'm gonna assume it 1.5% of area gross. Why? It's not your business, it's my business. I assume this value. It's up to me. So 0.015 area gross. So I'm gonna delete this term and put 0.015 area gross. I'm gonna delete this term and put 0.015 area gross. So right now, how many unknowns do you have in this equation? Only one unknown. So I can figure out the value of area gross. Be careful when you are doing your calculation. Please be careful. So it will be just a moment. $180.34 inch square. I'm gonna ask, what should I do with this area gross? Any answer? What should I do? Convert it to what? No, this is the issue. Not Oliver. No, not square. Not square. Guys, here I converted area gross and I got square because I need to convert it to square. This side equal this side. But right now, I'm looking to convert this area gross of concrete to circular shape, which equal by divide 4 times diameter square. That's right. That's right. So be careful. Please be careful. Area gross means area of concrete. You are a designer. What you need? You need to convert this area gross to what? What is the shape? You have three shapes: square, rectangular, column, circular. So you need to read your problem carefully, or in the real life, you need to figure what shape of cross section. So right now, I'm gonna equate this value equal pi divide 4 diameter square. So your diameter will be 15.15 inch. We don't like a number with fraction, with decimal numbers. So this is the minimum. I cannot go below this one. I cannot go below this value. I cannot assume the diameter is 15. 15 is unsafe. 15.15 is the minimum. You cannot go below this number. So I'm gonna assume it 16-inch diameter. Area steel. Do you remember? 1.5% of area gross. Your column right now is 16-inch. So your area steel will be 1.5 divide 100, which is 0.015, time area gross by divide 4 times 16 square. Your area steel will be 3.016 inches square. We need to convert this one to a number and size. Guys, there is a hint at the beginning of this slide number 8. Please make sure that at least we have 6 longitudinal bars must be used if you are talking about a spiral. Make sure your number of bars minimum is 6. For tight columns, the minimum is 4. But for spirals, the minimum is 6. So you are right now converting this area steel to number and the size. If you use, for example, number 5, if you are using number 5, what is the area of number 5? 0.31. So I'm gonna divide this area steel by 0.31. The number will be 10. 10 is good. 10 is good. Four, 8, 9, and 10. This distribution must be uniform distribution.
Dr. Amen?
Yeah.
The hint you pulled up on slide 8, it's under short column. This question doesn't specify if it's short or long column. So how would you, do we still use it anyways for any spiral ties, whether it's short or long column?
Long column or short column, it's another issue. You are talking about buckling. Buckling is considered or not. But if your column is a spiral or tied, you need to follow these rules regardless is it short or long. Okay? So I don't care my column is short or long. From the beginning, if your column is short, buckling is neglected. If your column is long, buckling is considered. It's another issue. Once you are done, considered or not considered the buckling, okay, forget it. We are talking about a new shapes or new types of column. If your column is tight column, I will design it like this. If your column is spiral column, I will use another equation. But these rules must be followed. Minimum, maximum percentage, minimum number of bars in a tight column or spiral column, whatever the column is. Okay? So I'm gonna put 10 bars, number 5. It's a good question, Oliver. No, this number, odd number or even number, is okay because you are talking about circular column. The big issue, I explained it before. The issue is if you have a number and you need to distribute this number in a square or rectangular shape, we need to maintain or keep symmetry. We need to keep this cross section a symmetric cross section. So if you put any number on this side, I have to put the same on the other side. If you put any number on this side, I have to put the same number on the other side. So finally, your numbers must be even number. But for circular column, no. Odd number can be accepted because you are distributing this number uniformly. Okay? We don't have issue with symmetry. On AutoCAD, you can use array, polar array to make this distribution. It's easy. So this number for circular column, I don't care, odd or even. We need to design spiral. Guys, I told you, if you are talking about a spiral column, we have 2 steps. Okay, I did this step first, that's fine. But I'm still looking for this step also. You have to do both of them. You need to tell me, this is spiral. What is the size? What is the bar used? And what is the distance between this point and this point? The pitch, S. So we have very little, 2 little equations. The first one, rho S equal 0.45 area gross divide area concrete minus 1 time F prime C divide F yield. Let me write it here. Rho S equal 0.45 area gross divide area C minus 1 F prime C divide F yield. Area gross by divide 4 time, what is the diameter? 16 square. What is the area C? Guys, around this reinforcement, we will put the spiral like this. So we have cover, concrete cover. I'm gonna assume it 2 inch or 2.5 inch. So anybody can tell me what is the inside diameter or what is the diameter of this spiral, which called DC? What is the diameter? If you assumed it 2 inch, what will be the diameter? 14 or 12? No, not 14. It's a 12, yes. Why not neither, Burak? You have 2 inch from here, and you have another 2 inch from there, from 16, you will have 12 inch. Okay, it's a good point, but we are looking for what is the diameter here. So we're gonna assume probably the clear cover is 1.5 inch. So I increased it to be 2 inch to include what you are talking about. These numbers are assumptions. Okay? Okay. So the area C will be by divide 4 times 12 square. The first value $201. The second one 113. Okay, go ahead and find rho S equal 0.45. 201 divide 113 minus 1 time F prime C. I believe F prime C, how much? 3,000 and 50,000. Your answer will be 0.021. Second equation, this rho S equal 4 AS DC minus DB divide S DC square. Okay, rho S equal, I forgot it, 4 AS DC minus DB divide S DC square. That's right. Yeah. So which size I'm gonna use? I'm gonna use number 3, spiral. Bar number 3, I will use it. So DB, diameter of this size, number 3, the diameter is 0.375. Area, the cross-section area for this size will be 0.11. 0.11. So rho S 0.021 equal 4, area is 0.11. DC 12 minus diameter of this bar 0.375. Divide S, the beach, S, I don't know what is the spacing. DC 12 square. The only unknown is the spacing. It will be 1.7 inch. So guys, the spiral will be number 3 and the distance, which called pitch of this spiral, will be 1.7 inch. If you would like to make this pitch or this spacing bigger, what should I do? If you would like to make this spacing bigger, if you are feeling 1.7 inch is very small, so what should I do? Guys, what should I do? Okay, try another size, number 4. If you are using a bigger size, I believe S will be bigger. Try it. What is the diameter? What is the area? Try these numbers and put them here. You will find this S will be bigger, probably 2 inch or 3 inch. Or probably will be double, maybe. I don't know. So guys, if you would like to design spiral column, you need to tell me what is the diameter of this column, what is the required area steel, and you need to tell me what is the design of the spiral. Designing of a spiral, you need to finish up your calculation to tell me what is the size I'm gonna use, what is the spacing, what is the pitch. Pitch means the distance between this point and this point. It's very important. Yeah. Okay. But using different rebar is more realistic because cover, it's not easy to increase or decrease it. So just to remind you, if you are designing a spiral column, you need to design a spiral, and then you need to design the column itself. Which one is the first one? It's up to you. For my example, I started with the design of the column itself. Then I designed the spiral. If you would like to start with the spiral, that's fine. But if you start with the spiral, how can I figure out the area gross for the concrete cross section? So you need to start to design your column first to be able to design the spiral. I'm gonna stop here. Designing of column under the effect of moment and axial force. We will continue on Friday. Any question?
Dr. Ayman, is this lecture going to upload now?
I'm sorry?
This lecture, will it upload right now, right away? Or
Yeah,
later?
yeah, automatically. No, automatically. It's uploaded automatically.
Okay, thank you, sir.
Okay.
Thank you.
It's a good question, Oliver. It's a very good question. Yes. If you open your tables, do you remember these tables? If you go down, 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 should be here. Probably after this. I'm not sure. Just a second. Here you go. Table A14. Table A14. This table can give you the size of the spiral and the pitch according to ACI. So what is the diameter of the first? What is the value of F yield? 60,000 or 40,000? Then what is the diameter of your column? For example, if your F yield 40,000, what is the diameter of the column? And then what is the out to out diameter of spiral, which called, we have two diameter. The inner diameter is DC. What is the value of the diameter of the spiral? What is the value of F prime C? I can tell you what is the size and the pitch. For example, this one, the size will be 3.8, which is 0.375 diameter. And the pitch, which is S, 1.75 inch. Okay. These are the minimum requirement. Okay. So this table in page 646 or table A14, based on what is the F yield of steel, what is the diameter of the column, the diameter of the column. And then based on what is the diameter of the spiral, which is called DC after you subtract the cover, then based on what is the value of F prime C, I can tell you what is the size and pitch S.